So for my project on Williams syndrome, I started with a picture of a girl with Williams syndrome just to kind of emphasize the expression that is characteristic of Williams syndrome. Because I think it's really hard to kind of describe like an elf-like face, and I also think that it is like, I think she looks very sweet in the picture, so I think that it's almost like an inviting, warm picture. Um, I got a comment disagreeing, but I think otherwise, and maybe that's just me. And then I start kind of with this quote, interesting quote to bring people in, and then I talk about another quote that kind of reinforces that. I introduce the founder of Williams syndrome, John Cyprian Phipps Williams, and then the co-founder, Dr. AJ Buren, as well as explain kind of the demographics, the likelihood, and who is most affected by Williams syndrome. Either it's a spontaneous genetic mutation or it's autosomal dominant transmission. Um, so it's most likely people who have family members with Williams syndrome, or people who are unfortunate and have the spontaneous generation of it. Um, then for my phenotype and symptoms page, I put another picture of just kind of emphasizing the characteristic traits of Williams syndrome. The large ears, the full cheeks, small jaw. And then I talk more about some characteristic traits over here, as well as the diagnostic process, and how it's typically diagnosed. And I think this is kind of like my favorite part of the project, where I talk about the comparison of development of the facial structures in a human versus that in a human without Williams syndrome and a human with Williams syndrome. And I think what I enjoyed so much about this section was being able to go through and like find the individual genes that played parts in these different phenotypic changes that we see in Williams syndrome. Because although it's not known like the function of all these genes, some of them like it is clear to a clear correlation has been drawn between the effect they have in a normal functioning human, a normal functioning chromosome 7 and a chromosome 7 with the deleted region. Um, and I think that's super interesting. Like, it's cool that mouse models can be used to to create single knockout mice that allow us to really elucidate the different or the changes in the phenotypes due to just one gene. And then I talk more here about the G2F2I and the G2F2RD1I gene. It's a mouthful, but now I've memorized it. Then in this page, I talk about deletion of chromosome 7 and how this is just a sequence showing that it can no longer be detected here, which is common, which is just the diagnostic process kind of once again. But I thought it was a cool image. I wanted to add that. And then I talk here more about comparison of mice models with and without certain genes. Talk here about the elastin gene, which is key to a lot of the cardiovascular difficulties that are seen in Williams syndrome. And then I included this graph talking about Williams syndrome's progression and how it phenotypically looks in children as they age. Talk here about treatment and therapies. Most common things are stenting and patching the aorta, and that is because of the cardiovascular difficulties that people face. And then in my final page, I talk about the current research on Williams syndrome. I included this kid because, once again, I think kids are warm and endearing, and they're the ones who most of the research is being currently done on Williams syndrome for. I also added this chart talking about the difference in phenotypic expression if it is maternally or paternally inherited, just because I found that interesting. And then I also added more charts talking about more genes. Talked about why a mouse model, just to kind of explain why that makes sense. And then I added this researcher as well, because I think she's doing really important work on finding new innovative techniques to treat patients with or children with Williams syndrome. And that is it. Last page is my references, and I hope you enjoy it. Thank you.